Hey class, welcome back to Chemistry 1032 Lab. I am your host, Dr. Russell Betts, and today we're talking about identification of elements. Elements make chemistry. The atoms that are part of those elements bond, do all kinds of nice things. Elements. Today we're going to talk about them, and we're going to talk about some of the cool things you can do with them, and about how you identify them, and some of their properties and characteristics. Part 1, we're going to identify elements based on the emission of lights. Now, you've all seen fireworks. You've all seen it. You've all seen street lights, kind of yellowish color. You've all seen all kinds of different things. Okay. Whenever you heat up an element, especially metals, especially metal salts, especially if you burn them, they burn with certain color. It's really kind of cool. Fireworks, for example, when you see them explode in the air, and you see all these brilliant white lights or brilliant blues or reds, those are different elements causing that color. It's very cool. Talk a little more about that later. Part 2, identification of elements based on molar mass. One of the most common numbers we work with in chemistry is molar mass. It's found on the periodic table. It's written under the element symbol. It's very common. It's so freaking powerful. We're going to work a little bit with that too. And in part 3, we're going to go around the house. We're going to identify nonmetals versus metals. The two most common classes of elements are metals and nonmetals. There are metalloids as well. And we're going to go around the house and identify them just based on property. Okay? It's going to be kind of fun. Part 1, identification of an element based on the emission of light. It's cool, guys. I wish we could do this at home. It's just too dangerous. Open flames, buying a lot of inorganic salts. We're not going to do this at home. I'm going to do it for you on a video. It's no problem. It's kind of fun. We're going to light a Bunsen burner. Bunsen burner is going to burn. And we're going to put certain salts. Literally, there are salts in solution. And we're going to burn them. And you're going to note down what salt it is I'm burning and the color that it gives you. And you'll be surprised at some of the beautiful colors we can get from salt. And doing this experiment, you're going to identify two unknowns just by color. Very simple, very fun. Part 2, identification of elements based on molar mass. So today we're just going to do a quick calculation. It's not hard. It's very simple. I'm going to do on a video, I'm going to have a piece of metal that's very similar to this one. And written on that piece of metal is on a flag on this piece of metal is the number of moles. You're going to want to write that down. Not my number, not this number right now, but when you watch the video. You want to write that number down. I'm going to put this piece of metal on the scale. We're going to get a mass. You're going to want to write the mass down as well. Molecular mass is grams over volume. Pardon me, that's density. Molecular mass, or molar mass, is grams divided by moles. So if you know the grams by putting it on the scale, you know the moles by reading it off the flag, simply divide the grams by the moles and you'll have molar mass. Now, with that molar mass, you can go to the periodic table, find an element that has the same or similar molar mass, and you can identify or at least make a very good guess at what element you're dealing with. Let's say we pick up a piece of metal in the lab and it has a flag on it that says it has that many moles. So let's write that down. Moles equals 0.1459 moles. And we throw it on the scale, and the scale tells us we have that many grams. So grams equal 15.736 grams. So this is the data we have. We want to know molar mass. We know that molar mass equals the grams of an element divided by the moles of the element. So in this particular example, grams go on top because it's grams per mole, right? So get your handy dandy calculator out. 15.736 divided by 0.1459 equals 107.85. Oops, let's do this correctly now. 1.7.8 grams. I'm sorry. Pardon me. 0.9 grams per mole. And you go to the periodic table, you take a look around, try to find 107.9, and what you'll find, silver. So that element is more than likely silver based on its molar mass. Okay? And that's how you solve these kind of problems in part 2. Part 3, identification of metals versus nonmetals. Now, the periodic table is broken down into 3 distinct classes of elements: metals, nonmetals, and metalloids. Now, metals are on the far left of the periodic table, nonmetals are on the right of the periodic table, and around this thing we call the staircase, or I've always called the staircase or the stair steps, those are metalloids. Now, metalloids are on the top and the bottom of the staircase. So imagine you're walking up the stairs. Metalloid, 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 metalloid. They're also on the bottom of the stairs. Metalloid, 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 metalloid. So these are your metalloids right here. Now notice I cleverly avoided this square right here. This is the square for aluminum. Aluminum is not a metalloid, so it's an exception to the rule. Everybody else on the top and the bottom of the staircase, oops, this one, 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 those are metalloids. The exception, though, even though it's on the bottom of the staircase, is aluminum. Aluminum is a metal. Make no mistake, aluminum's a metal. Okay? So, on this side of the staircase, we have our metals. On this side of the staircase, we have our nonmetals. And let me put maybe some magenta X's in them. These are your metalloids. Now there's exceptions again. Always exceptions. This element here is hydrogen. It's a nonmetal. It's placed in group 1 for other reasons, but it's not a metal. It's a nonmetal. Okay? So, and we're going to go through our home, and we're going to find different metals that are in our life and different nonmetals that are in our life. And how can you tell them apart? Well, metals, first of all, are almost always very shiny. Some metals are quite dull in comparison, but they all have some kind of luster or shine. Metals are generally flexible. Now, depending on the thickness of the metal, you may not be able to bend it with your hand. But a paperclip, for example, is definitely metal, and you can definitely bend it. It's very flexible. And metals are great conductors of heat and electricity. You know that for yourself. Your cooking pots at home are made of some kind of metal. Maybe aluminum, maybe cast iron. Maybe maybe you use ceramic, that's a non-metal, but you probably use a metal. Okay? Your plumbing, your water coming into your home is copper. The wires in your walls for electricity is also copper. These things conduct electricity very well. Some non-metals in your life, your pencil lead on your pencil is not made of lead. It's a holdover. It's made of carbon. It's graphite, which is the element carbon. If you have double paned windows in your house, the gas between the window panes is probably argon. It could be nitrogen, but it's probably argon. The air you're breathing right now is basically 80% nitrogen. So it's not pure nitrogen, but it's definitely very, very, very enriched with nitrogen. There's a bunch of other stuff too. You can just go take a look around your house, see if you can find some metals and some non-metals that are in your life. Now, metalloids in the pure form are quite rare in everyday human life. Silicon, for example, is a metalloid. It's used in computer chips, but it's usually in the compound form. It's not the pure element silicon. Boron, for example, also, you don't see it very often in our society as the pure element, but you do see it being used as part of medicines and stuff like that. Okay? All right, guys, and that's the end of part 3. And with that, I want to wish you all good luck and good chemistry. We'll see you soon.